The bidirectional reflectance distribution function, or BRDF, is a big, long, and frankly intimidating name. However, if we break it down, we can see that it is just a function that is used to describe the reflectance properties of a surface, or how light interacts with a surface. There are many common BRDFs for use already in 3D applications. However, most software have taken strides to support PBR in recent years, which has led to the influx in applications providing PBR-capable BRDFs. These functions draw upon all of the topics discussed here in Section 3 in order to create a standardized workflow which is capable of producing consistent results between artists and all lighting conditions. For the BRDF to be physically plausible, it must encompass aspects such as energy conservation, Fresnel, and microsurface detail. It must also take into consideration diffuse and specular reflection. By mirroring the sciences of our real world, we are better able to capture realistic surface information for use in 3D. We have discussed a lot of topics in this section, many of which may still be hard to completely grasp. If you feel that you are barely keeping afloat, do not worry. As artists, it is our job not to worry about the physics to make things work. However, it is important to be aware they exist in order to maximize our creativity. 3D applications have adopted the PBR/BRDF culture in some form or another, and having an understanding of what is required to utilize these functions is where we begin in the next section.